Okay, so today I have the opportunity to share with you a small piece of my research on the role of androgen in female reproduction. Okay, so human reproduction is regulated by the hypothalamic pituitary gonadal axis, or the HPG axis for short. In the hypothalamus, there are a group of neurons that secrete gonadotropin-releasing hormone, or GnRH. This hormone then acts on gonadotrope cells that reside within the pituitary. These gonadotrope cells respond to GnRH by secreting luteinizing hormone, or LH, and follicular stimulating hormone, or FSH. These two hormones then act on the ovaries to induce ovulation and steroidogenesis and the production of estrogen. This estrogen can then act with both positive and negative regulation at the levels of the hypothalamus and the pituitary. However, this is not always the case. In disease such as polycystic ovary syndrome, or PCOS, the HPG axis is dysregulated. PCOS affects 1 in 10 women and is the leading cause of infertility in women of reproductive age. What we see in this syndrome is elevated levels of luteinizing hormone. Therefore, this affects the ability of women to ovulate, and therefore you get infertility. You have decreased levels of estrogen and increased levels of testosterone, and it is thought that testosterone is the driving force occurring in this syndrome. My hypothesis is that testosterone can directly act on gonadotropes within the pituitary to increase luteinizing hormone. What we know about the gonadotrope cell is that when GnRH binds to its receptor, you get increased intake of glucose through the glucose transporter GLUT1, and then this leads to more secretion of luteinizing hormone. Because androgen has the ability to increase glucose uptake in other tissues, we believe that the same thing will happen in gonadotrope cells. So we tested this by isolating primary gonadotrope cells from mice and incubating them in vitro with androgen. We were able to show that androgens do modulate transcription of the protein of GLUT1 by looking at mRNA. It can also modulate the translation of GLUT1 looking at protein, but the data I want to show or share with you today is the translocation of GLUT1. And we imaged this with microscopy. We labeled GLUT1 protein green, luteinizing hormone red so that we can identify gonadotropes, and our nuclei are labeled blue with DAPI. So you see in our control that the green, there's a little bit of GLUT1 here. When we add DHT, or dihydrotestosterone, a type of androgen, we see an increase in the amount of GLUT1 within the cell. When we treat with GnRH, its natural stimuli, you get some GLUT1 on the outer edge of the cell, meaning that now GLUT1 can perform its function at the membrane. However, when we look at a combination of DHT and GnRH, we see a large increase of GLUT1 at the cell surface. And this data supports our model here to the left that androgens can help induce glucose uptake and therefore LH secretion. And this is the hypothesis that we are currently testing in the laboratory. So if you have any questions about this project and would like to talk about more ideas, I'd love to speak with you after. Thank you for your time.